some idea like this, no? This is the okay. This is speed regarding. Now I'm giving even the length of arrows also. That will indicate what? The magnitude of speed. What about the strain? So can we talk about the stress? As where strain will be maximum? The strain will be maximum here only. Let me choose a few set of points. Okay, we have 1, 2, 3. Let me give the number 1, 2, 3. Stress at point 1 will be more. The reason for that, their slope is more. So how we define strain? Strain should be delta R or elongation change in length by original length. So this should be equal to how much? Very, very important. So students will often go somewhere. So you know to bother. So from where I brought it, the idea is from here. Oh, where we are? Potential Ng. Yeah, I had to slide up further. See, from here, look at delta R minus delta X will be the change in length. Change in length by original length. What do we get? Half into dy by dx whole square. What is dy by dx? Nothing but slope. I'll write this part. Again, copying paste may not permit. These are very important in books. What happened? The author assumed, the author thought that okay, students will manage. So don't think again that when books are not discussing, you are discussing very fine. So it's a very well, elasticity. The author thought, okay, students will manage on their own. So from where I brought it, so this, what is the formula? Elongation delta L should be equal to delta R minus delta X. This should be equal to delta X by 2 dy by dx whole square. Delta L by delta X is what? So this is nothing but you can write dy by dx whole square, or this will become. So if I give slope, can you tell how much of strain? Yes. Can you tell how much of stress? What is the stress? Young's modulus into strain. So this will be y by 2. Tell me like a where slope is more. If slope is more at 1 than 2 at 3, no? So where stress will be more. When the wave propagates, the stress will be maximum. If a wave propagates such that where stress will be maximum here, if at all, if the rope breaks up, gets fractured, where do it can happen? It can happen at mean position. That's what you mean to say. We have to be very careful. Those points which are at mean position, there only the stress can be maximum and there only the fracture can happen. Don't think that any point on a rope, when it is at mean position only, there can be a fracture. Because as I keep on increase speed, the tension will increase and so definitely the rope will have maximum breaking stress, and it depends upon slope also. So these are the some ways of testing student. The slope depends on what? You know that one. Amplitude, omega. So there are so many things what happen when you go to the lab, no? So you need all this background. You cannot just go for pick up any amplitude, any frequency. You should work out what is the breaking stress of a wire. And the stress developed at mean position should not be greater than breaking stress. If that happens, the wire, the rope may get cut, the strings may get cut, and there'll be some fracture also. Cracks will come. So these are the things what happen, they have to take care. Okay, so what I can call now, stress at 1. Very important. If you see the, I think SC Orma, he has asked this one. Huh? He has tested students with the stress idea. So from where the stress is brought, again from the basic mathematics here. They'll say Young's modulus of the material. Okay, fine. So any doubts you have, you can clarify, because this is something very good conceptual way of asking questions for you. And this is what we are going to use in next coming chapters, the idea of this one. Anybody, if having doubts, you can clarify it. Huh? Okay, nothing. So we just took where the tension is constant throughout the length of the rope. That is what our discussion we made. Now, sir, like if mu varies, what shall we do? If mu varies, we are going to integrate, because what all we did is like with mu constant. You look at the derivation. How I brought, I assume that the mu is constant. I'll start from here. Yeah, this one. So the idea of mu, it has come here, no? If mu also can be variable, huh? In that case we can manage, because the, I think from from rho, I'll bring the, so this rho is there, no? From rho open, I'll bring back the mu. If mu is variable, I'm going to take small element, then I'm going to integrate, then I'll proceed further. So some of the books, what happen, even the linear mass density is going to vary is asking. So let's not bother that. In that case, what happen, we'll go for pulse cycle. It'll be very lengthy calculation. Just have an idea that one. If mu is variable, what you're going to do? Rho, you're going to write it as mu by s. Mu by s. And the mu what happen varies as a function of x. So mu equal to mu naught x. Then you carry further. Okay, there's only theoretical. I think some questions here and there available. You can take them and try to work out few. So that'll be sufficient. So there's one independent topic about only the energy of a wave. Hmm? Energy, power, and intensity. So we will, I think this is not possible. Numericals, tomorrow I'll discuss the overall numericals. As far as I think I feel now, the total theoretical idea is got completed. So what all we have to just focus only on the different types of numericals. I think we have plenty of time. Tuesday, Wednesday, Thursday, Friday, 4 days are there. We'll discuss wide varieties of numericals. Hmm? Because the 2 days earlier last week we did know. So that advantage now what we have. Hmm? So shall we end up the class? Hmm? Okay, any doubts you can put in WhatsApp, and please start working on numericals on this one. Transverse wave on a rope. Don't pick up standing wave. Living standing wave, you can work out all the numericals like a phase, speed, time taken by the wave to move from one point to another. All these things are available. Anybody having doubt, you can clarify now only. It will be very easy to explain. Okay, then, yeah, see you.